Right now, you believe you are choosing to watch this. You could pause it, close it, walk away. The decision feels weightless. Open. Yours. Physics isn't so sure. The same equations that steer galaxies, ignite stars, and hold every atom of your body together make no exception for the matter inside your skull. And if those equations tell the whole story, then the next thought you have was never truly open. Not influenced. Not nudged. Fixed. 2 centuries ago, a French mathematician imagined a mind that could see every particle in the universe at once. And he realized something terrifying. For such a mind, the future would not be a mystery. It would be a memory. Every war, every love, every choice you will ever make, readable in advance from the arrangement of matter on the day the universe began. Scientists hoped quantum mechanics would shatter that machine. It found randomness at the heart of reality, and randomness surely means the future is open. But look closer, and the escape route begins to crumble. Because a random choice is not a free one. And when physicists set out to test whether nature could be hiding a script, using light from quasars that began its journey billions of years before the Earth existed, they pushed any possible conspiracy billions of years into the cosmic past, without ever ruling it out. A controversial idea called superdeterminism still stands, the possibility that every decision was locked in at the Big Bang. Most physicists reject it. Some, including Nobel laureate Gerard 't Hooft, take it seriously. The trail doesn't end in deep space. Einstein's relativity hints that your future choices may already exist, written into spacetime, as real as your past. And in laboratories on Earth, neuroscientists have detected patterns of brain activity that can predict simple decisions before people report making them. Tonight, we follow the evidence to the end, through the clockwork of the planets, down into the particles of your brain, out to the oldest light in the cosmos, and toward one question waiting at the bottom of it all. If every choice you will ever make was already written into the universe, could you ever have chosen differently? On the banks of a river in what is now Turkey, 2 armies are killing each other. The Lydians and the Medes have been at war for 5 brutal years, and today the fighting is at its peak. And then the sun begins to disappear. Not behind a cloud, not below the horizon. It is being eaten in a clear sky in the middle of the day. Darkness pours across the battlefield. Stars appear where stars should be impossible. And on both sides of the river, soldiers lower their weapons and stare upward, because every one of them draws the same conclusion. The gods are watching. And the gods are furious. The battle stops. The war ends. Right there. Kings who had spent 5 years trying to destroy each other sign a peace treaty, because the sky told them to. This is what the heavens were for almost all of human history. Not a place, a power. An eclipse was rage. A comet was an omen of plague, of famine, of the death of kings. The one thing everyone knew, the one thing that was obvious, was that the sky answers to no one. And yet, here is the detail from that ancient battlefield that should stop you cold. According to the historian Herodotus, that eclipse had been predicted. A Greek philosopher named Thales, he tells us, had announced in advance the year the sun would vanish. How Thales did it, even whether he truly did it, historians still debate. For 2,000 years, that question waited. Astronomers in Babylon, in China, in Baghdad kept records, centuries of observations tracking every wandering light. They found patterns, cycles. The sky, it turned out, kept schedules, but nobody knew why. Until one man, working alone while a plague shut down his university, found the answer. And it was so much stranger than magic. Isaac Newton discovered that the force pulling an apple toward the ground and the force holding the moon in the sky are the same force. One force, one law, written as a single line of mathematics. You've heard that story before, but almost everyone misses what it actually meant, what it did to the human view of reality. Because before Newton, there were two worlds. Down here, the ordinary world of falling objects and rolling stones. Up there, the divine world of the heavens, running on rules of its own, if it had rules at all. Newton erased the border. The same equation governs a cannonball and a comet, a raindrop and a ringed planet. The heavens are not another realm. They are just more matter, obeying the same law. And that law made a promise no religion had ever dared to make. It said, "Give me the present, and I will hand you the future." Tell me where the planets are tonight, their positions, their speeds, and the equations will tell you where they must be tomorrow. Not where they might be, where they must be. No choice, no mood, no mercy. It sounded like arrogance, so the universe was put on trial. In 1705, Newton's friend Edmund Halley studied the records of a bright comet, the ancient omen of doom itself, and noticed it had visited before. The same object, returning again and again on a roughly 76-year orbit. So Halley did something no human had ever done. He looked at the most feared apparition in the sky and gave it an appointment. The comet, he announced, would return around 1758. Understand what a prediction like that costs. Halley was promising a rendezvous with the heavens that he could not possibly live to see. He died in 1742, 16 years short. And then, on Christmas night 1758, a German farmer and amateur astronomer named Johann Pallich pointed his telescope at the sky. And the comet was there, rising out of the darkness, essentially as a dead man's mathematics said it must. Its arrival shifted only slightly by the tug of the giant planets, a delay astronomers had themselves calculated. The terror of ancient kings reduced to a train arriving on schedule. But the sky had one more test, the hardest one. By the 1840s, astronomers had a problem. The planet Uranus was misbehaving, drifting off course, wandering from the path Newton's equations demanded. And here, at the edge of the map, the old idea should have won. This is where the gods should have lived. Instead, a French mathematician named Urbain Le Verrier made an assumption so bold it borders on madness. "The law is not wrong," he said. "The universe is hiding something." If the equations say Uranus is being pulled, then something must be pulling it. And from nothing but the wobble, he calculated the ghost, its mass, its orbit, its position. A world no human eye had ever seen, conjured out of pure mathematics. He mailed the coordinates to an observatory in Berlin. On the night of September 23, 1846, an astronomer named Johann Galler aimed his telescope at the exact patch of sky the letter described. Neptune was waiting there, less than 1 degree from where the pen said it would be. Think about what happened that night. A man discovered a planet, an entire world 4.5 billion kilometers away, without looking. The universe had stopped merely obeying our equations. It was taking orders from them. And it has never stopped. This is the part of the story that isn't history, it's your daily life. We don't wonder about eclipses anymore. We publish their schedules, mapped to the second, for the next 1,000 years. When engineers fired the Voyager probes across the solar system, they threaded them through the moons of Jupiter and Saturn using slingshot maneuvers plotted years in advance. And after billions of kilometers, the spacecraft arrived within moments of the timetable. Ancient kings begged the sky for mercy. We send it instructions. Which brings us to Paris in 1814, and to the man who was brave enough, or reckless enough, to say the quiet part out loud. Pierre-Simon Laplace was the greatest expert on celestial mechanics alive. The man who had taken Newton's law and shown that the solar system runs on it like clockwork, no divine adjustments needed. When Napoleon himself asked why his great book on the heavens never mentioned God, Laplace is said to have replied with 7 of the most fearless words in the history of science. I had no need of that hypothesis. But Laplace saw something in the equations that almost no one else was willing to face. The mathematics that finds Neptune doesn't care what it's aimed at. It never asks whether the matter is large or small, distant or near, dead or alive. So Laplace imagined the ultimate astronomer, a mind vast beyond imagining, that could see the position of every particle in the universe and every force acting upon it, all at once. For that mind, Laplace realized, the equations would do what they always do. They would take the present and hand over everything else. Nothing would be uncertain, he wrote. The future, just like the past, would be present before its eyes. We call it Laplace's demon. And before you dismiss it as philosophy, remember what you've watched it do in this story alone. The demon's method, measure the present, compute the future, is not a theory about reality. It is the single most successful strategy the human race has ever discovered. It ended the terror of eclipses. It kept a dead man's appointment with a comet. It found a world with the point of a pen. Every time we have aimed it at the sky has surrendered. But the demon's gaze doesn't stop at the sky. Because if Newton taught us anything, it's that there is no border, no line where the law of the heavens ends and some other rulebook begins. The equations apply to all matter, the distant, the near, the matter reading the coordinates, the matter holding the pen. And right now, roughly 1.5 meters above the surface of a spinning planet, there is a small, warm collection of particles, about 10 trillion of them, that has listened to this entire story while quietly assuming it was about something else. Comets, planets, distant lights, It was never about the lights. That collection of particles is you. And the question the demon has been patiently waiting to ask, the question this entire documentary hangs on, is whether the mathematics that found Neptune in the dark has already found your next thought. Come back from the sky now. Come all the way in. Past the planet, past the clouds, through the roof of the room you're sitting in, into the dark behind your forehead, into the 1.5 kilograms of matter that is, right now, deciding to keep watching this. It doesn't look like much. A soft, folded object, mostly water, running on about 20 watts, less power than the bulb in your refrigerator. But inside it, at this very second, is a storm unlike anything else we have ever found. 86 billion neurons, trillions upon trillions of connections. An electrical and chemical tempest of almost unimaginable complexity. And somewhere inside it, tonight's decisions are forming. What to eat, when to sleep, whether to finish this video. And the question Laplace's demon left us with is brutally simple. Is that storm exempt? When the equations swallowed the comets and the planets, is there a line drawn at the skull? A border where the mathematics stops and something else, something free, takes over? For most of history, the answer was obvious. Of course there's a line. Matter is one thing, mind is another. A body was just clay, and something else, something immaterial, moved it. A spirit, a spark, a ghost in the machine. Nearly every culture on Earth agreed on this, and honestly, look at the evidence they had. A living hand moves because you want it to. A dead hand, identical in every visible way, moves for no one. Something clearly leaves. Something that wasn't matter. The first crack in that wall appeared in the strangest possible place. A dead frog. Bologna, Italy, in the 1780s. An anatomist named Luigi Galvani is dissecting frogs near one of the new electrical machines when his metal scalpel touches a bare nerve in a severed leg at the very moment the machine sparks. The dead leg kicks. No spirit, no soul, no frog in any meaningful sense. Just a leftover piece of biological machinery. And yet, given a spark, it moves like a living thing. Galvani had stumbled onto something enormous. What his experiments began to reveal, through years of dispute, refinement, and argument, was that the machinery connecting nerve to muscle was not beyond physics. Electricity was part of the message. The discovery detonated through Europe. Showmen electrified corpses for horrified audiences. A young writer named Mary Shelley turned the nightmare into Frankenstein. But beneath the theatre, a serious and unsettling idea was taking shape. If the command to move travels as something physical, then the ghost had just lost one of its jobs. Still, surely the will itself was untouchable. The spark of intention. That, at least, must be instantaneous, immaterial, beyond measurement. Then, in 1850, a German physiologist named Hermann von Helmholtz did something his own colleagues considered almost blasphemous. He measured the speed of thought. The experiment was beautifully simple. Stimulate a nerve at two different points along a frog's leg. Time the muscle's response from each. If the command of the will travels like spirit, the difference should be zero. Spirit doesn't commute. Helmholtz found a delay. Small but real and perfectly measurable. The signal crawled along the nerve at roughly 30 meters per second. Slower than sound. Slower than a diving falcon. Your commands, the orders of your will, travel through your body like traffic. Sit with how strange that is. When you decide to move your finger, the instruction takes a measurable fraction of a second to arrive because it is a physical pulse of charged atoms shuffling through membranes, obeying the same laws as everything else. The will has a speed limit. Ghosts don't. And that discovery points at something modern physics has made astonishingly precise. Because physics has done something remarkable. It has taken a complete inventory of the known forces of nature. There are four. Gravity, which sculpts galaxies. The strong force, which welds atomic nuclei. The weak force, which lets stars burn. And electromagnetism, light, chemistry, electricity, everything else. And of those four, almost everything your brain does, at the scale of neurons, molecules, and chemistry, is governed by one: electromagnetism. Every neuron that fires tonight fires because charged particles, sodium, potassium, calcium, surge across a membrane. That's electromagnetism. Every memory you have is stored in the strengths of connections built by molecules. Chemistry, which is electromagnetism. Every emotion is a chemical tide. Every thought you have ever had, every love, every regret, every act of what you call choosing is, at the level of physics, the same force that powers a bolt of lightning, paints the aurora across the poles of Earth, and carries starlight across billions of years of empty space to reach your eye. The storm in your skull is not a different kind of storm. It's the same fire as the sky, folded small. And here is the quiet, devastating result of 2 centuries of looking. Physics has found no special force that switches on when matter begins to think. No new interaction appears at the boundary of the skull. As far as any experiment can tell, the particles inside a brain obey the same physical laws as particles everywhere else. No known exemption, no border at the skull. So now the demon closes in, and we have to follow the logic where it goes. Take one decision. Say, later tonight you reach for tea instead of coffee. It feels spontaneous, free, yours. But rewind the tape. You chose tea because a particular pattern of neurons won a competition in your brain. That pattern won because of the precise state of your synapses tonight. And that state was set by this morning, by yesterday, by how you slept, what you ate, who you spoke to. Keep rewinding. Those synapses were sculpted by years you barely remember, by a childhood you did not design, by a language you did not select, by a brain whose wiring diagram was drafted by genes you did not pick, handed to you by 2 people you did not choose, who met by circumstances no one controlled. Keep going. Before the genes, a planet, assembled from a cloud of dust that collapsed 4.5 billion years ago because of density ripples it inherited from something earlier. Keep going. The chain does not stop. That is the whole horror of it. Every link is caused by the link before, and the recession only ends at the beginning of everything, at the arrangement of matter and energy on the first morning of the universe. Now state the problem plainly, because it deserves to be said plainly. You did not choose your genes. You did not choose your childhood. You did not choose the state your brain was in 1 second ago. And in the classical picture we have followed so far, the physics of Newton and Laplace, genes, history, environment, and the physical state of your brain are enough to carry the chain forward on their own. Nowhere in that machinery is there an obvious gap labeled you, some extra lever standing outside cause and effect, waiting to get first say. The you that feels like it's deciding arrives at the end of the process, not the beginning. This is what Laplace's demon sees when it finally turns its gaze from the comets to the skull. Not a mystery, not a mind, just more matter, configured exquisitely, folded into the most complex object we have ever found. But matter, obeying like everything has always obeyed. To predict your next thought, the demon doesn't need to understand hope or fear or tea. It only needs the particles. And the particles have never once said no. Case closed then. The sky surrendered. The frog surrendered. The neuron surrendered. Freedom was a beautiful rumor, and Newton had killed it 2 centuries early. Except for one problem. Newton was wrong. Not about the planets, not about gravity, his equations still fly our spacecraft today, but about the deepest assumption beneath Laplace's demon, that matter at bottom runs on rails. In the first decades of the 20th century, physicists digging into the atom made the most shocking discovery in the history of science. The universe does not keep perfect appointments. At the deepest level we have ever reached, beneath the neuron, beneath the molecule, down where your brain dissolves into particles, the clockwork comes apart. Nature, at bottom, appears to roll dice. When that discovery broke, you could almost hear the sigh of relief around the world. The chain was cracked. The demon was blind. And surely, somewhere in that beautiful randomness, freedom had been hiding all along. It's a wonderful thought. It survives about 5 minutes of scrutiny. Because when you actually look at what the dice do, and what they would mean for the storm inside your skull, the escape route leads somewhere no one wanted to go. Not back to freedom. Somewhere stranger. "29 people are gathering for a photograph outside a scientific institute. They look ordinary. Dark coats, stiff collars, a few uncomfortable smiles. They are not ordinary. 17 of them have won, or will win, the Nobel Prize. Einstein sits front and center. Marie Curie is beside him. Behind them stand Bohr, Heisenberg, Schrödinger, Dirac, Pauli, nearly every mind that built the modern picture of the atom, collected in a single frame. It is probably the greatest concentration of genius ever captured in one photograph. And they are in the middle of a war. Not over money or priority or fame, over something much bigger. Whether the universe, at its foundation, makes sense. Because the theory these people have just finished building, quantum mechanics, the physics of the very small, works magnificently. It predicts the outcomes of experiments with accuracy no theory has ever approached. But it has a strange, scandalous hole in its heart. You can see the hole in a device simple enough to sit on a desk. Take a piece of glass, half mirrored, so that light has a 50-50 chance of passing through or reflecting away. Now send photons at it, single particles of light, one at a time. Each photon reaches the glass, and each photon chooses through or back, left or right. Ask the deepest theory in science why this photon went left when the last one went right. Identical photons, identical glass, identical everything. And quantum mechanics gives an answer that would have made Newton physically ill. There is no why. At least, none that standard quantum mechanics gives us. The theory predicts the probabilities with breathtaking precision. But for the individual outcome, this photon, this moment, it offers no deeper cause. As far as the standard theory is concerned, the 50-50 is not merely our ignorance of hidden machinery. It is where prediction ends. Machines built on quantum processes like these are already used to generate random numbers for cryptography. Numbers designed to be fundamentally unpredictable according to everything the standard theory says. Einstein hated it. Hated it with his whole soul. His protest became the most famous sentence in 20th century physics. God does not play dice with the universe. For 30 years, he hunted for the hidden clockwork beneath the randomness, and never found it. Laplace's demon, meanwhile, quietly died. Think about what this does to everything we built in the last two parts. The demon's power rested on one promise: that the present fully contains the future. Measure everything now, compute everything later. But if no information in the present, accessible even in principle, uniquely determines which outcome comes next, the prophecy fails. Not because the demon is weak, because the future, at the deepest level, is not fully written in the present. The demon, at least in its classical form, was dead. The chain of cause and effect that ran from the Big Bang through your genes into your next thought had a broken link. You can imagine the relief. And it wasn't just newspapers and philosophers celebrating. Serious scientists, among them Nobel laureate Arthur Compton and the great astronomer Arthur Eddington, argued openly in the 1930s that quantum uncertainty had reopened the door to human freedom. The clockwork universe was dead. The future was loose. Surely, in the gap where causes used to be, the will could finally live. It is one of the most seductive ideas of the modern age. Now, watch it fall apart. Let's take the escape route seriously, completely seriously, and see where it actually leads. Suppose your decisions really are wired to quantum events. Tonight, choosing between tea and coffee, imagine the deciding vote deep in your brain comes down to one genuinely random quantum flicker. Through or back? Tea or coffee? The universe rolls. The dice land. Tea. Here is the question that kills the celebration. In what sense was that your choice? You didn't cause the flicker. If the standard theory is right, nothing caused the flicker. It didn't consult your values, your memories, your hopes. It didn't consult anything. It was an accident, a perfect, pristine accident that happened to occur inside your skull. If your arm shot out and knocked over a stranger's cup because of a random neural spasm, no one on Earth would call that an act of free will. They'd call it a twitch. Randomness doesn't give you the dice. It just means the dice throw you. A Geiger counter sits beside a radioactive sample. clicking at genuinely unpredictable moments. The purest randomness known to nature, right there on the table. Nobody has ever suggested the Geiger counter has free will. Adding more clicks doesn't add more freedom. So why would a brain be different, just because its randomness is wetter? And now the trap closes. The real trap, the one this entire episode was built around. Be precise about what's being trapped. If free will means this, that in exactly the same physical universe, atom for atom, you could genuinely have chosen otherwise, then look at what we've done. We've examined both kinds of event the universe offers. If an event is determined, locked in by prior causes, then it was fixed before you arrived, and you could not have done otherwise. If an event is undetermined, genuinely random, then it came from nothing, answers to nothing, and it wasn't you doing the choosing. Determined or random, caused or uncaused, and neither box seems to hold the third thing this kind of freedom demands: an action not fixed by the past, not produced by chance, yet still, somehow, authored by you. In 400 years of looking, through telescopes, through microscopes, through equations of magnificent precision, physics has never found that third box. Whether it must exist for freedom to mean anything, hold that thought. It returns at the very end of this story, with a twist. There's a final irony, and honesty demands we include it. Even the assumption we just granted, that delicate quantum events directly steer decisions in the brain, is itself deeply controversial. The brain is warm, wet, and relentlessly interacting with everything around it. Conditions under which long-lived quantum coherence is, in general, extraordinarily hard to maintain. And at the scale where neurons actually fire and networks actually compute, neuroscience has so far needed no quantum magic to explain what brains do. A few serious thinkers push back. The Nobel laureate Roger Penrose, together with anesthesiologist Stuart Hameroff, has proposed a controversial model in which quantum processes inside structures called microtubules play a role in consciousness. Most neuroscientists remain unconvinced. The question is not fully settled. But notice, it doesn't need to be. Because even if some quantum event does influence a decision, the philosophical problem stands exactly where it stood. Replacing a determined cause with an unpredictable one does not create an author. Dice, no matter where you hide them, do not add up to a self. So the great quantum escape fails twice over. Probably too fragile to matter, and even if it matters, randomness was never freedom to begin with. The 20th century's most shocking discovery broke Laplace's chain and offered nothing to put in its place. Determinism says your choices were inevitable. Quantum randomness says some of them were accidents. Neither says they were yours. And there this story might have ended, a clean, bleak verdict, if not for one assumption sitting so deep beneath everything that, for 50 years, almost nobody thought to say it out loud. We've been assuming the dice are honest. That when nature rolls, the roll is fresh, connected to nothing, correlated with nothing, a genuine surprise even to the universe itself. But what if that's the illusion? What if the randomness is a performance, and the outcomes were quietly coordinated long ago, behind the curtain, before any laboratory, before any Earth? It sounds like paranoia, perhaps even untestable. But physicists realized they could do something extraordinary. They could make the conspiracy work for its secrecy. If some hidden common cause was coordinating both the particles and the experimenter's choices, they could force that coordination backward. Not years, not centuries, but billions of years into the cosmic past. And to do it, they needed an experiment whose crucial ingredient had begun its journey long before the Earth existed. In a laboratory in Vienna, they reached across the observable cosmos and borrowed light from the edge of time. "12 billion years ago, before the Earth, before the Sun, before a single grain of the dust that would one day become you, a particle of light left home. Its birthplace was a quasar, the blazing heart of a young galaxy, where a supermassive black hole tears matter apart and lights it brighter than 1,000,000,000,000 suns. The photon escaped that furnace and fell into the dark. And then it did the only thing light can do. It traveled. While it traveled, the universe grew up around it. Galaxies collided and merged. Generations of stars were born, burned, and detonated. A quiet yellow star ignited in an unremarkable spiral arm. Planets condensed around it. On the third one, oceans formed. Life crawled out of them, and a species appeared that told stories about the sky. Empires rose. Newton wrote his law. Laplace imagined his demon. And still the photon traveled, 12 billion years without touching anything at all. Until one night in January 2018, on a mountaintop in the Canary Islands, it fell into the mirror of a telescope built by a species that hadn't existed for 99.99% of its journey. That photon was not caught for astronomy. It was caught to answer a question. Maybe the strangest question ever put to an experiment. Is the universe hiding a script? To understand why anyone would ask, we have to go back to 1964 and to a soft-spoken physicist from Belfast named John Bell. Bell worked at CERN designing particle accelerators. That was the day job. His obsession was the thing Einstein had gone to his grave unsatisfied about. Whether quantum randomness was truly random, or whether hidden machinery, invisible instructions carried inside particles, decided every outcome in advance. For decades, that debate had been dismissed as philosophy, untestable, career poison. Bell found a test. Here is the essence, with no mathematics needed. Quantum mechanics says you can create two particles, two photons, say, bound together in a single state, then send them far apart. Measure one here, one there, and the results are correlated. Ask why, and the common sense answer is the one Einstein favored. The particles left home carrying matching instructions. Like a pair of gloves separated into two boxes and mailed across the world. Open one box, find a left glove, and you instantly know the other is a right. No mystery. No magic. The answers were written down at the start. What Bell discovered, in a short paper published in an obscure journal that folded soon after, is that this common sense picture has a breaking point. He proved that if the particles carry locally pre-written instructions, answers packed into each particle at the start, with no influence reaching between the distant measurements, then the correlations can only reach a certain strength, a hard mathematical ceiling. And quantum mechanics predicts that entangled particles smash through it. Suddenly, philosophy had become an experiment. Prepare entangled pairs. Measure. Count. If the correlations stay under Bell's ceiling, Einstein was right and there's a local script. If they break it, no such script can exist. The experiments began in 1972 and grew more airtight for 50 years, culminating in the loophole closing tests of 2015 and a Nobel Prize in 2022. The verdict, repeated in laboratory after laboratory on every continent, is one of the most confirmed results in modern science. Again and again, the ceiling breaks. Be careful what this does and does not mean. No message passes between the particles, you cannot use entanglement to send a signal, and nothing usable travels faster than light. But the gloves in boxes explanation, the ordinary, local set of instructions Einstein hoped for, cannot explain what the experiments see. Whatever nature is doing, it isn't that. Except. Buried in Bell's beautiful proof, there is an assumption. So obvious, so seemingly innocent, that it went almost unexamined for decades. Bell himself knew it was there and said so plainly. The proof assumes the experimenters are free. Every Bell test works like a cross-examination. To catch the particles without a script, you must question them unpredictably, choosing at random at the last instant which property to measure. The logic only holds if those choices are genuinely independent of the particles, if there is no connection between what the particles carry and which questions the physicists happen to ask. But what if there is? Follow the thought, uncomfortable as it is. The measurement choices are made by machines and brains. Machines and brains are matter. You sat through part 2, you know this. And every piece of matter in that laboratory, the random number generators, the photons, the physicists, their breakfast, their childhoods, shares a common past. Rewind far enough, and everything in the room descends from the same early universe. If some correlation planted in that shared past quietly links the particles' behavior to the choices that will one day be made about them, then Bell's ceiling means nothing. The particles aren't beating a fair cross-examination. They know the questions in advance. Take that possibility all the way, that the particles and the choices of what to measure were never statistically independent, not once, anywhere in cosmic history, and you arrive at the territory physicists call superdeterminism. Not just that your tea versus coffee choice is caused, but that the very questions scientists ask of nature are correlated from the beginning of time with the things they ask about. The dice aren't just determined, they're loaded, and so is the hand that rolls them. An idea like that is extraordinarily hard to test, but a team of physicists from Vienna and MIT realized you could do something remarkable. You could measure exactly how deep such a conspiracy would have to run. Their reasoning was surgical. The choice of measurement must be made by something. Whatever makes it shares a causal past with the lab, unless you find a decision-maker whose past barely overlaps with Earth at all. So don't let the choice be made on Earth. Let the universe make it. That is why, on that January night in 2018, 2 telescopes on a Spanish mountaintop were aimed at 2 quasars on opposite sides of the sky. One whose light had traveled 7.8 billion years, the other, the photon whose journey opened this chapter, 12.2 billion. Between the 2 measurement stations, a source generated pairs of entangled photons. And here is the beautiful, audacious mechanism. For every single pair, the measured color of the quasar light arriving at that instant slightly redder or slightly bluer, dictated which measurement each detector performed. Within microseconds of hitting the mirror, ancient light was deciding the questions. Think about what that means. The free choice in this experiment was delegated to the measured colors of photons whose journeys had begun billions of years before the experimenters existed, before the Earth, before the Sun, before the Milky Way looked anything like it does tonight. If something coordinated these choices with these particles, it did not happen in the lab, or in the physicists' brains, or anywhere in the recent universe. The detectors counted. Roughly 17,000 entangled pairs in one run, 30,000 in another. The ceiling broke again. The correlations held at full quantum strength, which forces any hidden coordination back and back and back. The team did the accounting. For a local conspiracy of this kind to explain their data, it would have to have been arranged at least 7.8 billion years ago, excluding such an explanation from roughly 96% of the space-time volume of the experiment's own causal past. In plain language, any conspiracy exploiting this loophole would have to reach unimaginably deep into cosmic history, committing to its rigging before the Earth, before the Sun, before half of cosmic time had passed, storing the script in the light of quasars, waiting for a species to evolve, build telescopes, and ask. For most physicists, that settles it. A conspiracy that patient, that vast, that flawless is not an explanation. It's a horror story. They move on. But not all of them. Gerard 't Hooft, Nobel laureate, one of the architects of modern particle physics, takes superdeterminism seriously and has spent years building models of a fully deterministic layer beneath quantum mechanics. The physicist Sabine Hossenfelder has argued publicly that the idea is unfairly dismissed. They are a small minority, and it's only fair to say so plainly. But here is what should give you pause. The broad loophole they point to cannot be closed simply by finding a more distant, more ancient, more ingenious source of randomness. Because every experiment designed to test nature must choose what to measure. And superdeterminism questions the independence of that choice itself. Moving the choice farther away, even to the edge of the observable universe, does not by itself escape that circle. And that exposes something almost never said aloud. Science itself runs on the assumption we've been questioning for 4 chapters. Every experiment ever performed assumed the experimenter could have asked differently. If the strongest version of superdeterminism were true, the unsettling possibility is not merely that our theories are incomplete. It's that the universe fed us our own questions. Most physicists refuse to walk through that door, and they may well be right to refuse. So let's grant it. Set the conspiracy aside. Assume the dice are honest, the choices independent, the cosmos innocent. Because Einstein, who started this whole war over the dice, left behind a second, entirely separate challenge to your freedom. One that has nothing to do with quantum mechanics. No entanglement, no hidden scripts. It needs only the speed of light and the geometry of space and time, the most tested, least disputed physics we own. And it hints at something stranger than any conspiracy. It suggests your future decisions may not be waiting to happen, that they may already be there, woven into the fabric of the universe as real as your past, and that somewhere out there, in principle, the universe already contains the answer to a question you haven't asked yourself yet. To see it, we don't need a laboratory at all. We need a stranger, on a bicycle, in the Andromeda Galaxy. There is a belief you hold so deeply that you have never once thought to say it out loud. You believe in now. Right now, as you watch this, you feel that a single, universal present moment is unfolding everywhere. Right now, somewhere in the Andromeda Galaxy, something is happening. You can't see it. Andromeda's light takes 2.5 million years to reach us. But surely, at this very instant, something is happening there. The universe, you assume, is a vast stage where one moment, this one, is briefly, blazingly real. The past is gone. The future doesn't exist yet. Reality is the thin, glowing edge in between, sweeping forward like the tip of a pen across a page. Every decision you've ever made rests on that picture. Choosing feels like standing at the pen's tip, at the exact place where the unwritten becomes written. In 1905, a young patent clerk quietly took that picture away. Einstein's reasoning began with a single measured fact. Light always travels at the same speed for every observer, no matter how they move. It sounds harmless. It is not. Follow it carefully, as he did, and something extraordinary falls out of the mathematics. Observers moving differently through the universe cannot agree on what is happening now. For two events separated so widely that no signal, not even light, could travel between them in time, different observers can disagree about which happened first, or whether they happened together. And here is the crucial part. None of them is wrong. There is no master clock hiding behind the universe, no cosmic control room where the true now is kept. Each observer's now is sliced at a slightly different angle through reality, and every slice is equally legitimate physics. For events close together, the disagreement is trivial. Nanoseconds, nothing. But stretch the distance, and the slices begin to swing wide. Which brings us to the stranger and the bicycle. Picture someone, something, in the Andromeda Galaxy, 2.5 million light-years away. It doesn't need advanced technology for what it's about to do to you. It needs a bicycle. When it sits still, its now slice through the universe crosses Earth on a particular day, say, your today. But when it pedals gently in Earth's direction, at nothing more than cycling speed, its slice of what is happening now on Earth tilts. And because the lever arm is 2.5 million light-years long, that tiny tilt sweeps across weeks of Earth's timeline. Pedal away from Earth, and the slice swings weeks into what you call your past. Pedal toward Earth, weeks into what you call your future. Let's be precise about what this is not. The cyclist cannot see that future, cannot know it, touch it, or send a single bit of information back from it. This is not time travel, and no telescope in Andromeda will ever show them next week's Earth. It is something quieter and stranger, a disagreement, permitted by the laws of physics, about which distant events count as happening now. And yet, the quiet version is unsettling enough. Because, depending on which way that cyclist happens to be rolling, its perfectly valid now includes a version of you from last month, or a version of you dated next week, on the far side of the decision you're currently agonizing over. The physicist Roger Penrose, the same Penrose from Part 3, sharpened this into one of the most unsettling thought experiments in relativity. Imagine an alien civilization in Andromeda debating whether to launch a fleet toward Earth. Two people walk past each other on an ordinary street, one strolling toward Andromeda, one away. Because of their motion, their equally valid now slices differ out at that distance by days. For one walker, the aliens' council hasn't yet decided. For the other, the decision is made. The fleet is already in flight. Two humans passing on a sidewalk, and relativity refuses to say which of them is right, because within the physics, both are. Now run the argument, because you can feel where it's pointing. If someone's perfectly legitimate now already contains the alien's decision, in what sense was that decision still open? And the aliens are not special. Swap the roles. Out there, at cosmic distances, ordinary observers moving at ordinary speeds have valid now slices that pass through your next week, your next year. Follow that reasoning to its end, and you arrive at one of the most powerful ways of interpreting relativity, a picture physicists call the block universe. Take every event that has ever happened or ever will, every star's birth, every raindrop, every human choice, and lay them out in 4 dimensions, 3 of space, 1 of time. In this picture, that entire block is the real object. Your life is not a dot moving along a line, it is the whole line, a strand woven through space-time, from cradle to grave, all of it equally present in the geometry. The choice you'll make next Tuesday sits at its coordinates the way Neptune sat at its coordinates before any telescope looked. And what you call now appears nowhere in the equations. It is not a place in physics, it is a feeling, something brains do, a spotlight your consciousness carries, not a property the universe has. Einstein himself was deeply sympathetic to this view. When his oldest friend, Michele Besso, died, months before his own death, Einstein wrote to the grieving family, "For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. If the past still exists back there, and the future already exists up ahead, then your choices do not create anything new. The pen isn't writing the page. The page was never blank. You don't make decisions. You encounter them, one by one, in the order your consciousness moves along your strand, each one feeling perfectly fresh, perfectly open at the moment you reach it. Now, a hard, honest pause. Because this chapter must not overclaim. What you've just heard is an argument, not a measurement. The relativity is rock solid. The slicing of now genuinely is observer-dependent. That has been tested beyond reasonable doubt, and no physicist disputes it. The contested move is the step from the slices disagree to therefore the future is already fixed. Philosophers and physicists have pushed back for a century. Some argue that simultaneity across millions of light years, where no signal can connect the events, is partly a bookkeeping convention, not a fact about what exists. Others defend pictures where the past is real, but the future genuinely isn't, a block still under construction, growing at its edge. And whether quantum mechanics, with its unresolved randomness, breaks the frozen block or fits neatly inside it, is exactly the kind of question that keeps physicists arguing at 3 in the morning. So, no, relativity has not proven that your future exists. But notice what it has done, because this is the part that survives every objection. It has removed the support. That intuitive picture you've carried your whole life, The moving edge of now, the open future condensing into fact at the moment of choice, appears nowhere in the physics. Nothing in the equations flows. Nothing in the mathematics marks tonight as the present. The equations themselves simply do not draw the boundary you feel so vividly, the line between a settled past and an open future. If that openness is real, it is invisible to the most precisely confirmed theory of space and time we have ever possessed. The openness of your future is not something physics shows us. It is something we keep insisting on, from the inside. And that phrase, from the inside, is where this entire investigation must finally go. We have spent 4 chapters outside, among comets and equations, photons and quasars, geometry and light. And none of those witnesses has given us the freedom we went looking for. Now there is only one witness left, the room where the feeling of choosing actually lives. Because while physicists were interrogating the cosmos, another group of scientists went looking for free will in the one place everyone assumed it was safe: inside the human skull, in the warm dark where you decide. They wired brains with electrodes. They watched decisions being born. And they found something that neither Newton nor Einstein nor the quantum pioneers ever predicted. They found that by the time you feel yourself choose, your brain may have already begun. Freiburg, Germany, 1964. 2 young neuroscientists, Hans Kornhuber and Luder Dieker, are sitting in a cafe, frustrated. The great questions about the brain, will, intention, the origin of action are considered untouchable, unmeasurable. Philosophy's territory, not science's. Over coffee, they decide to try something anyway, with the crude tools of their time. They will record the brain's electrical whisper through electrodes on the scalp at the exact moment a person freely decides to move. The signal they are hunting is buried in noise 1,000 times louder. So they do something clever. They ask volunteers to flex a finger again and again, thousands of times, whenever the urge strikes. Then they align all those recordings at the instant of movement, stack them and average, letting the random noise cancel itself out. What emerges from the noise is a slow, rising electrical wave in the brain. It begins almost a full second before the movement. They name it the Bereitschafts potential, the readiness potential. And at first, it seems merely interesting. Of course, the brain prepares before acting. Preparation takes time. Nobody yet sees the trap coiled inside the discovery. It takes almost 20 years and one American physiologist to spring it. Benjamin Libet's question sounds innocent. The brain's preparation begins about a second before the movement. Fine. But where in that second is the decision? Where is the moment you would swear is the origin of the whole thing, the moment you choose? Everyone knows the obvious answer. First you decide. Then the brain prepares. Then the finger moves. Conscious will starts the chain. That's what it means to be the author of your actions. Libet built an experiment to timestamp the will itself. San Francisco, 1983. A volunteer sits watching a dot sweep around a clock face like a fast second hand. The instructions are simple. Whenever you feel like it, entirely up to you, flick your wrist. And note precisely where the dot was at the moment you first felt the urge to move. Electrodes on the scalp capture the readiness potential. The clock captures the feeling. For the first time in history, the brain's preparation and the experience of deciding can be laid on the same timeline. Here is what the timeline showed. The readiness potential began rising roughly 550 milliseconds before the movement. The reported feeling of deciding arrived at roughly 200 milliseconds before the movement. Look at the order. The brain's preparation was already underway, about a third of a second underway before the moment the volunteers experienced as the birth of their decision. The feeling you would stake your life on, "I just decided to move," showed up late, not at the start of the chain, partway down it. Libet himself was shaken. He spent the rest of his career wrestling with his own result. And when the finding detonated through science and philosophy, the headline version traveled around the world. The brain decides before you do. Free will is dead by electrode. But this documentary has earned the right to be more careful than the headlines. So let's see how far the evidence actually goes. And it goes far enough to be deeply uncomfortable without any exaggeration at all. First, the effect did not go away. It got bigger. In 2008, a team led by John Dylan Haynes in Berlin put volunteers in an fMRI scanner with a button in each hand. Press left or right whenever you wish. Reading patterns of activity in the frontal and parietal cortex, their computers could predict which button a person would press, seconds before the person reported deciding. In some analyses, the predictive information appeared as much as 7 to 10 seconds early. And here, the honest number matters more than the dramatic one. The predictions ran around 60% accurate. Not 90, not perfect prophecy. A loaded coin, not a script. But pause on what even that means. 10 seconds before you experience the pristine, weightless feeling of freely choosing left, a machine reading your cortex already had information, weak, imperfect but real, quietly tilting the odds toward the answer you would eventually give. Whatever conscious choice is, its story seems to begin earlier than the moment you become aware of it. And there is a second line of evidence, stranger and in its way more unsettling, about what that feeling of deciding actually is. Some patients with severe epilepsy once underwent a radical surgery, severing the corpus callosum, the great cable connecting the brain's two hemispheres. The seizures stopped. The patients lived normal lives. But in the laboratory, neuroscientist Michael Gazzaniga could now do something impossible in an ordinary brain: show information to one hemisphere and hide it from the other. The speaking half of the brain, almost always the left, could be kept entirely in the dark about why the right half had just made the body act. In one famous session, a patient's right hemisphere was shown a snow scene, and his left hand, which the right hemisphere controls, correctly picked a shovel from a set of objects. His left hemisphere, the talking one, had seen only a chicken's claw. Asked why the shovel, the speaking brain did not hesitate, and it did not say, "I don't know." It said, "The shovel is for cleaning out the chicken shed." A fluent, confident, instant explanation, and a complete fabrication. The talking mind had no access to the real cause of the action, so it wrote a story in which it did, and crucially, it believed the story. Gazzaniga called this left hemisphere system the interpreter, and its existence reveals something unsettling the human brain is capable of, generating a sincere, seamless feeling of "this action was mine, done for my reasons," after the fact, about actions it did not consciously originate. The feeling of willing, at least sometimes, is not the engine. It's the press office. Now, the counterattack. Because this is a live scientific battlefield, and you deserve to see both armies. Libet himself never accepted the death of freedom. He pointed out that in his window between brain preparation and action, there was still time, perhaps 150 milliseconds, for consciousness to veto the movement. We may not initiate freely, he argued, but we can cancel freely. Not free will, but free won't. Others attacked the experiment's foundations, reporting the position of a moving dot at the instant of an inner feeling is exactly the kind of timing judgment brains are bad at. And in 2012, the neuroscientist Aaron Scherger offered the deepest challenge of all. Perhaps the readiness potential isn't a decision signal at all. Neural activity constantly drifts and fluctuates like weather. Perhaps the brain simply acts when background activity happens to crest past a threshold, and Libet's method, averaging thousands of trials aligned to the movement, could produce the appearance of a smooth rising wave out of those fluctuations. On Scherger's reading, the famous ramp isn't the brain deciding early, it's just the tide coming in. And beyond all that stands the largest objection. Flicking a wrist is not choosing a career, a partner, a life. No electrode has ever time-stamped a decision that took years of deliberation. The lab has only ever caught the smallest fish. So be honest about the scoreboard. Neuroscience has not proven that your brain settles everything before you're aware of it. The experiments are contested, the interpretations are at war, and the field is genuinely unresolved. But now, stand back, all the way back, and notice something every version of this debate leaves untouched. Libet's readiness potential is a brain process. The veto he proposed, another brain process. Scherger's drifting fluctuations, brain processes. The interpreter spinning its stories, the slow deliberation that unfolds over years. All of it happens inside the physical machinery we met in Part 2, built by genes and history that no one chose. In 70 years of watching decisions being born through electrodes, scanners, and split brains, neuroscience has found competitions, thresholds, cascades, memories, predictions, and narrators. What it has not found is a boundary, a place where physical causation stops and an independent author steps in from somewhere outside the chain. Inside the skull, the chain continues, and with that, the investigation is complete. 5 chapters of testimony, the equations that found Neptune, the dice that answer to nothing, the quasar light that pushed the conspiracy loophole billions of years into the past, the geometry that won't draw a line between your settled past and your open future. And now the electrodes, catching the feeling of choosing, arriving late to its own event. The verdict writes itself. Case closed, for real this time. Except for one thing, one fact we have quietly ignored since the very first chapter, sitting in plain sight underneath every equation and every experiment. A fact about what it would actually take to compute you. Because Laplace's demon has a weakness. And when you see it, the entire meaning of the story you've just heard begins to turn inside out. The universe may have written your every choice, but here is what no one and nothing inside it may ever be able to do. Read them all in advance. The King of Sweden announces a prize. Oscar II, a monarch with a genuine love of mathematics, will reward the greatest unsolved problem of the age, and the problem he chooses is the oldest one in this documentary: the clockwork sky itself. Newton's equations can handle two bodies, a planet and its star, with perfect elegance. But add just one more, three bodies pulling on each other all at once, and the mathematics becomes a nightmare no one has ever tamed. The King's challenge? Prove the solar system is stable. Prove the clockwork runs forever. The greatest mathematician alive takes the bait. Henri Poincaré works for years, submits a brilliant manuscript, and wins the prize. The memoir goes to press, and then, while checking a final detail, Poincaré finds a mistake in his own work. Not a small one, a crack that opens onto an abyss. He telegraphs the printers in a panic. Nearly every copy is recalled and destroyed, and Poincaré pays the printing costs himself, more than the prize money, to bury the error. What he publishes instead, after months of feverish repair, is not the proof the king asked for. It is the discovery that the proof is impossible. Poincaré found that in the three-body problem, there are configurations where the tiniest change in the starting positions, a difference too small to measure, too small to name, grows, and grows, and keeps growing, relentlessly, exponentially, until two systems that began almost identically are doing completely different things. The equations remain perfectly deterministic. Nothing rolls dice. And yet forecasting collapses, because any uncertainty in the present, however microscopic, eventually swallows the future whole. We now call this chaos, and in the 20th century, it turned up everywhere we looked. In weather, where it sets the hard horizon on every forecast. In rivers, in heartbeats, in dripping taps. And, the great irony of our story, in the sky itself. Modern computations show the orbits of the planets are chaotic on long timescales. Push the clock a few 100 million years forward, and the tiny uncertainties in today's best measurements swell until the planet's positions become uncomputable in practice. Simulations even find a small but real chance that Mercury's orbit unravels over the coming billions of years. Read that again slowly. The clockwork sky, the very machine that taught Laplace to believe in his demon, lies beyond the reach of any forecast we could ever actually make. Understand precisely what chaos revealed, because it is subtler and more interesting than a dead demon. Laplace's demon, as defined, perfect knowledge, exact to infinitely many decimal places, could still, in principle, run its prophecy. Chaos doesn't touch the fantasy. What chaos destroyed was something else: the assumption that determinism and predictability are the same thing. They are not. A universe can obey exact laws, top to bottom, while remaining forever out of reach of any observer who knows its state only approximately. And approximately is the only way anything real has ever known anything. And our universe raises the bar further still. It is not classical. Quantum mechanics, as we saw in Part 3, places fundamental limits on what can even be jointly specified in the way Laplace imagined. Whatever demon you try to rebuild for the real world has to survive quantum theory too. And the demon's troubles may run deeper than measurement. Because think about what the demon actually is. To be more than a fantasy, it must exist, physically, somewhere, made of matter, inside the universe it wants to predict. Now the arguments turn strange and beautiful. A simulation of the universe in perfect detail must store the state of every particle, in memory built from particles. The map presses up against the size of the territory. Stranger still, prediction changes character when the thing being predicted can hear the prediction. The announcement itself becomes a new physical event, a fresh cause, feeding back into the very future it describes. A demon working from inside reality would have to include in its calculation itself, its prediction, and your reaction to receiving it. A hall of mirrors that has fascinated logicians and physicists for a century. And there may be a final limit, quieter than all the others. Some systems seem to offer no shortcut between their present and their future. No compressed formula, no skipping ahead. To learn what they will do, you must let them run. The idea is sometimes called computational irreducibility, and whether the human brain is such a system, no one has proven. But if it is, then the shortest computation of you is you. Let that reframe everything, carefully, honestly. For 6 chapters, Your Choices Are Determined quietly felt like your choices are already known. Somewhere the answer sheet exists and you're just the last to see it. But look closely, that never followed. A future can flow completely from the past without existing anywhere as a finished prediction, without a cosmic ledger, without an answer sheet, without a single mind or machine in all of reality holding a copy of your next thought. Determination is not the same as foreknowledge. And if there truly is no shortcut through the storm behind your forehead, then your deliberation is not theatre performed over a result computed elsewhere. Your deliberation may be the computation itself. And this is the moment to reopen the question we left hanging in part 3. Remember the trap. Determined isn't free, random isn't free, and physics offers no third box. We asked, quietly, whether freedom actually needs one. Here, at the end, is the case that it doesn't. Ask what you truly wanted free will to mean. Did you want your choices to come from nowhere? Uncaused, unconnected to everything you are? Look closely at that wish. A choice untouched by your memories, your values, your loves, your scars, wouldn't feel like freedom. It would feel like possession. What you actually want, what you've always wanted, is for your choices to come from you, from your reasons, your history, your character, weighing a future only you can weigh. And that, determinism never took away. The causal chain doesn't bypass you, it runs through you. It doesn't puppet your deliberation. Your deliberation is one of its working parts. A real cause, with real effects, as legitimate as gravity. When you chose T, the choosing wasn't fake. A competition of values and memories genuinely happened, and its winner genuinely moved your hand. You are not a passenger inside the machine, watching. You are a segment of the machine, the segment that remembers, imagines futures, compares them, and cares about the difference. Philosophers call this view compatibilism, freedom as self-governance rather than self-creation, and it stands today as one of the dominant positions in contemporary philosophy. Not a consolation prize, a redefinition of what the prize always was. Does it change how we judge each other? It should, a little. A person's cruelty has causes, so does their kindness, and no one, anywhere, assembled their own starting conditions. Understanding that should make us slower to hate, the way we don't hate an avalanche. But notice, we still build barriers against avalanches. And human brains, unlike avalanches, are precisely the kind of machinery that responds to reasons, to consequences, to praise, to being held to account. Responsibility survives, not as cosmic bookkeeping, but as one of the causes that shapes what brains do next. So, after the comets and the frog, the dice and the quasars, the geometry and the electrodes, where does the verdict land? Honestly, like this. The freedom of folklore, the ghost outside the chain, the self that could have done otherwise in an atom-for-atom identical universe. Physics has found no clear trace of it, and much of what we've seen pushes hard against it. But the freedom that matters, a decision that cannot happen without your memories, your reasons, your deliberation, a future that flows through your thinking rather than around it, that one is untouched. Better than untouched. It may turn out to be the only kind that was ever on offer. And the only kind you ever actually needed. One more thing. The last one. 13.8 billion years ago, everything there is erupted from a beginning we still don't understand. Hydrogen cooled and gathered, stars ignited, forged carbon and iron, and died to scatter them. A yellow sun caught fire, a wet rock cooled, chemistry learned to copy itself, and copies that sensed the world outlived copies that didn't, until, on one branch of one lineage, matter folded into an object complex enough to look up. And tonight, that object, a temporary arrangement of stardust wired by a history it never chose, sat in the dark and asked whether it is free. If everything in this documentary is right, then that question was inevitable. Your watching was inevitable. This wonder you're feeling right now, inevitable. All of it, seeded in the initial conditions of the cosmos before the first star burned. The universe didn't just make your choices. Using you, your eyes, your storm of neurons, this very night, the universe chose to ask whether it is free. And perhaps there is no shortcut to what happens next. No demon standing outside the universe with the answer already in hand. No finished copy waiting for you to catch up. The decision happens here, through the only process in existence that has your memories, your reasons, your fears, your hopes. So go on, decide something. Whatever it turns out to be, in the entire history of the universe, you will be the first to know.